Hello everyone, and welcome back to the RF Explorer channel. For as long as aircraft have been manufactured, companies have invested millions of dollars and hundreds of hours into testing each completed design. This was more the case in the early days, when the only way to really test a new plane, helicopter, or rocket was to launch it and see what happened. Nowadays, with sophisticated computer models and drastically improved engineering techniques, aircraft designers can more or less approximate how the final model will perform. Still, that doesn't eliminate the need for extensive, often extreme testing. Whether designed to test the entire vehicle or just a single component, post-assembled aircraft evaluations are still very important for both military and civilian planes. Boeing is one of the biggest producers of commercial aircraft in the world and has been for over 100 years. Through all those years, the company has been highly regarded for its commitment to testing, whether designing planes for the military or one of its many airline clients. Boeing is a company that likes to know what its planes can do. One of the ways they push them to the limits is through what's known as vertical takeoff tests. This has the pilot leaving the runway and immediately pulling back on the flight controls. As a result, the aircraft immediately enters a vertical climb that it would almost never execute with passengers aboard unless there were a serious emergency. During the evaluation, the pilots will also perform several other maneuvers, such as sharp turns and descents, to ensure the aircraft can do everything asked of it. These types of demonstrations are common at air shows. Whenever a company like Boeing puts out a new model plane, international air shows are a great way to show them off to potential buyers. Like Boeing, French aerospace company Airbus makes both commercial and military planes. This is 400 meters. Atlas is one of the larger transport planes made by the company, 148 feet long and a wingspan of 140 feet. Despite being 173,000 pounds empty, this turboprop-powered airplane is fully capable of taking off at a near vertical angle. In fact, the Atlas is surprisingly agile for a large cargo plane with a top speed of Mach 0.7 and a large wing area. The plane can execute a number of impressive turns and maneuvers in order to get a comprehensive view of a plane's capabilities. Airbus, Boeing, and other major manufacturers will put their aircraft into extreme scenarios. One of the most important of these is extreme weather testing. Planes have a number of important components and systems that could be susceptible to extreme cold. In some places is where these aircraft must operate. Temperatures can reach dozens of degrees below zero. Ice weather testing is therefore essential for any aircraft to get its company's stamp of approval. The same goes for hot weather testing, which can cause different parts of the aircraft to expand and behave differently. Air is also less dense, which affects how the plane flies and turns. When testing its A330, Airbus made sure to perform what's known as a negative gravity test. Aircraft can be subject to this negative gravity for brief periods, especially during turbulence. The pace at which this is done either lengthens or shortens the duration, which can produce different results when flying an airplane with passengers. One of the worst case scenarios will be to lose an engine. When this happens, the plane immediately loses a significant amount of thrust. This means it will no longer be able to maintain its maximum speed or altitude. To see how their 7879 Dreamliner will react with an engine out, the Boeing team had the test crew perform a series of Airbus takeoffs. These include taking off with a sudden loss of thrust just before or after takeoff. This was followed up by the velocity for minimum control on ground test, or VMCG. During this exercise, the pilot maneuvers down the runway and turns off an engine. The pilot must immediately compensate with the rudder to stop the plane from drifting off the runway entirely. The goal is to make sure the airplane can safely recover from such an event without going more than 30 off course. This Boeing 7478 is undergoing a particularly high-risk test known as a rejected takeoff. It is designed to recreate a situation in which the pilot or ground control decides to abort an aircraft takeoff at the very last second. During the test, the pilot must slam on the plane's brakes while moving at more than 200 mph down the runway. The test was first performed under normal conditions. After the 7478 passed, it was loaded to its maximum takeoff weight of 975,000 pounds Even under these worst-case scenario conditions, the pilot was able to bring the plane to a safe stop. A side effect of the test was that the wheels became overheated, which meant they had to be deflated to protect firefighters from potential explosions. Pilots will tell you that every runway comes with its own challenges. One of the most notable difficulties is what's known as crosswinds. This is when runway configuration and weather conditions force pilots to deal with perpendicular wind forces, while comes with its own challenges. One of the most notable difficulties is what's known as crosswinds. This is when runway configuration and weather conditions force pilots to deal with perpendicular wind forces while coming in for a landing during these Airbus flight tests. Pilots must demonstrate that no special skills are required to land their aircraft, even with strong crosswind conditions. To accomplish this, pilots must use a technique known as the crabit approach. This is where the wings are kept level while the heading of the nose is slightly out of line with the runway. At the last possible second, the pilot must straighten out the plane, using the rudder, allowing the plane to touch down along the center line. One of the concerns Airbus has regarding its plane's performance is what's known as water ingestion. Commercial airplanes often have to deal with heavy rain, which can pool on runways, cause large splashes during takeoff. Unfortunately, turbine engines can sometimes stall or flame out when they ingest too much water. To avoid this, Airbus engineers designed the aircraft engines and landing gear in a way that would push water around the fuselage rather than out towards the engines. To test if this is working properly, a test runway is set up with multiple pools of water in a 350, then drives through them at varying speeds using both visual recording techniques and sensor data. Engineers can analyze how much water is ingested each time. At the McKinley Climatic Laboratory in Florida, the U.S. military has designed a massive climate control hangar where temperatures can be set anywhere between -65 and 165 Fa. In 2014, Airbuses, a 350 XWB, became the first of the company's aircraft to be subjected to all extreme conditions, from hot and dry to hot and humid, cold and wet, to simulated rain and snow. It may seem harsh or even a little cruel, but it's the only way today's aerospace engineers can be confident in the aircraft they produce. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.